So let's say we are given a function of z equals to this rational expression where we have 1 divided by x squared plus y squared minus 1. So we have to show that if this is what we are given, um, then x multiplied by the partial derivative of z with respect to x plus y multiplied by the partial derivative of z with respect to y is equals to minus 2z open bracket 1 plus z. Okay. So the only knowledge that we need to have when we are dealing with such questions is we just need to know how to go about partial derivatives. Okay. So the first thing that I would want to do in this case is I would first of all uh, want to differentiate what I have right here. Okay, what we have right there. How do we then go about it? So first of all, I'm going to find the partial derivative with respect to x. Then later I find the partial derivative with respect to y. Then I try to compare and see if after multiplying by x as well as y, then I try to see if I'll still have I'm going to have what I'm given right there. Okay, so we find the partial derivative with respect to x. So this is a rational expression, and I'm just going to convince myself to use the quotient rule, of which our u is simply the numerator, which is my 1, then meaning my u prime. Okay, and in this case all you have to remember is that you are differentiating with respect to u. For example, if I find that my u was y, meaning even my u prime was going to be 0, because I'm finding the derivative with respect to x, unless if maybe your y was multiplying x, that's when you have your first derivative, your u prime as the y. Okay, but because it's just a number, um it's just a number like this, then that just becomes 0. Okay, so what about our v? Our v is simply the denominator, which is x squared plus y squared minus 1. Then your v prime will be equals to. So one thing again to remember is that you are finding the partial derivative with respect to x. Hence, what you're going to have is simply 2x. So your y squared and your 1 or your minus 1 are simply constants. Hence, they're going to give you what? They're going to give you a 0. So that's really one of the points that we really have to keep in mind when we're dealing with such questions, is that let's say you are given just a bit further away from what I'm talking about right now, but not really further, but yeah, it will really help us in a lot of ways. So let's say you're given your z is equals to, let me say, your x squared plus your xy plus your, let me say you have a y and plus x, like that. So if I want to find the partial derivative of z with respect to x, what I need to keep in mind that I'm going to differentiate that one as well as that one as well as this one here. Then this one, that is like more like, I'll call it like a lonely y, is just on its own. And it's, I'm saying so because I'm finding the partial derivative with respect to x. So what I'm going to have here is a 2x plus a y, because when I differentiate my x there, I'm going to have a 1, and we are treating our y to be a constant, unlike what we used to do like when you're talking about functions of independent variables. Here we are talking about multivariable functions. So our y is more like a constant. It's like that time when you maybe have like your 2x. So in this case, more like our y is a 2. So we have our y there. So plus, so since we said our y, we treat it as a constant. Okay, so here we're going to have a 0 plus what? Plus 1. So even if again I was finding the partial derivative with respect to y, I was going to say this part here is a constant, so I'll get a 0 plus. This part here, my x is a constant, I'll get a what? I'll get x. Then this part there, I'll get a 1. My x is a constant, I'll get a 0, like that. Okay, so that's really one of the things that we have to keep in mind when we're dealing with such. It's very easy to make a mistake, most especially when you have, let's say you have your a function as that, then let's say you have another one that where they are multiplying each other. So if you really don't know how and where you need to treat one as a constant, it becomes a bit tricky to really come to a conclusion. Okay, so now let's try to find the partial derivative of z with respect to y. Okay, so in this case, we say our u is equals to 1, meaning our u prime is equals to what? Is equals to 0. Then our v is still the denominator, which is my x squared plus y squared minus 1 minus 1, um, then meaning my v prime, okay, v prime is going to be equals to, in this case we are differentiating, or like, let me say we are finding the partial derivative with respect to y instead of x. So meaning where this x, anywhere we see x, we just treat x as a constant. So this becomes 2y because I'm going to get a 0 here and a 0 there. Okay, so now let me try to continue from, like, from that, then we'll continue the other one later. So let's say we find the partial derivative with respect to x. So here, by using the quotient rule, I'm going to say uh, the partial derivative of z with respect to x, this is going to be equals to, we know how to do with quotient rule. I'm going to multiply u prime by v. That would be like 0 multiplied by x squared plus y squared minus 1. And then I'll say minus, I'm going to multiply u, which is 1, by v prime, which is 2x, like that. Then divide by what I get, I'm going to say my v squared. So that's y squared plus x squared minus 1, then you square it like that. This part is going to give us a 0, and what we end up with is simply is minus 2x divided by our x squared plus y squared minus 1 squared of that kind. Okay, so what about my partial derivative with respect to y? What is it? How is it going to be? Still, I'm still going to multiply my u prime by my v, of which my u prime is a 0. Then my v is x squared plus y squared minus 1. I'm going to subtract u by v prime. Okay, our v prime is 2y in this case, so we divide by v squared. So that's x squared plus y squared minus 1 squared, giving us minus 2y divided by our x squared plus y squared minus 1 squared, like that. So what you need to keep in mind is that what I have right here, okay, what you have there is simply what this was asking for. Okay, what you have right here is simply this part. Okay, so meaning the only thing that is remaining is for us to multiply by the x as well as the y. It's more like a bit of like coefficients and stuff. So in this case, if I say x multiplied by um, what we have there, okay, I'll bring it there, have to add a negative, like that. Then if I say again, let me say plus y okay, let's bring it right there. So just a matter of distributing the what I'll call coefficients for now. So this is going to give us like minus 2x squared divided by my x squared, okay, plus y squared minus 1 squared plus wait, that would be a minus, that would be 2y squared divided by x squared plus y squared minus 1 squared, like that. Okay, so what we observe now is that these are like two rational expressions, and you can just try to um, make it a single fraction. Okay, and what you observe, this is much straightforward because the denominator is simply the same for both, and what you need to do is that just to write it the way it is. That'll be your x squared plus y squared minus 1 squared, like that. Then the numerators, I'm going to factor out the negative 2 and say I have my x squared plus y squared, like that. So what I have here and what you have here is simply one and the same thing. Okay, so now remember to say what we need to have is minus 2z open bracket 1 plus z. That's what we need to have. Okay, so how do we then go about finishing this? So I know that my z, okay, my z is equals to that. Okay, but on the denominator, when I look at what I have my like x squared plus y squared minus 1 squared, of which is more like the denominator of z has been squared. But what I observe again is that this, what I have here, if I say for example z squared, I'm going to have something like 1 over um, my x squared plus y squared minus 1, not really squared there, then we do that and I say squared, of which this is just going to land me to 1 over x squared plus y squared minus 1 squared. If I say 1 squared here, it really doesn't make much of a difference because 1 squared is always 1. Hence, this is same as what we have there without a what? Without without saying 1 squared there. Okay, so what we are able to write is that at this stage I'm able to say instead of me putting this on the denominator, okay, I'm going to say I'm multiplying by what? It's more like I'm multiplying by 1 over, okay, my x squared plus y squared minus 1 minus 1 then squared like that. I talked about not putting it on the denominator, but this is still on the denominator, but I'm just trying to write it in a way that such that it's appealing to take it to what we have there. So it basically means what I have right here is also equals to what? Z squared. Hence I'm able to replace. Instead of writing it like this, I'll just say I'll multiply this by what? By Z squared. Or what should I do? Maybe to make it look a bit better, I'm going to say minus 2z squared, open bracket, x squared plus y squared, and I close like that. So we are not yet done, but we are close. We are so close to um, what we are looking for. So now, remember I have minus 2z squared, x squared plus y squared like that. So um, what about what I have here? How do I take care of that? So I would say, okay, but okay, um, I'm going to get this. Okay, what I observe is that I have my x squared plus y squared, which is simply this part. So I'll try to make it the subject of the formula and try to see if it's going to work out. It's not a guarantee that it's going to work out, but there's no harm in trying anyways. So I have like z is equals to, let me not choose but, let me just try to show here, but could I simply have meant, okay, I'll say but I'll just show it the way it is. Then I'll say but x squared plus y squared is equals to 1 plus z divided by z. So it's more like you had your z is equals to 1 over your x squared, um, okay, your x squared plus your y squared minus 1. You are trying to make your x squared y squared the sub of the formula, like you have a 1 there, do the cross multiplication. So you are going to have like your z, okay, that will be your x squared minus, I mean plus y squared minus 1 is equals to 1. So divide both sides by z, that you're going to have your x squared plus, let me do this, you're going to have your x squared plus your y squared minus 1 is equals to 1 over z. So here we are making x and y, I mean x squared plus y squared the sum of the formula. This is going to be x squared plus y squared is equals to 1 over z. Then you say plus 1, this one that is here, I add it. So my x squared plus y squared is equals to 1 plus z divided by z like that. Okay, so now that we know what that is, we can come now and say, okay, minus 2z squared. Here I'm going to write 1 plus z divided by z. Okay, so um, this can go, the squared can go, so it's more like we have like 2z z, then I have 1 plus z divided by z there. So this can go and that can go. Oh, I have a negative, yeah. So what we now have is minus 2z open bracket 1 plus z, and which is simply what we have there, hence shown. Okay, and that's simply how you go about it. Yeah. mm, this might not appear to be the easiest method, but at least it's appealing, and It's just a matter of knowing how to deal with partial partial derivatives. Yeah, so that's all in this video. Thank you very much for watching.